Hey there everyone, Hitesh here, back again with another video, and in this video we're going to talk about what is container, and with the help of a couple of diagrams it's going to become absolutely clear what is container. Now in case you are new here on this channel, make sure you hit that subscribe button and check out other videos on the Docker series, and more will be coming up. Now moving forward, there was an issue in the previous video that a lot of you were saying that we are on Windows Home Edition, and in case you are on the Windows Home Edition, then installation of the Docker is with the extra step that comes in. Now Docker is kind of a virtualization, and we're going to talk about that more in the next video about the virtualization and the difference between a virtual machine and the Docker. That's going to come up in next video. But right now, let me just help you to understand that what we are going to do if you are a Windows Home user. Now I'll link this description in the this link in the description section so that you can also read it. Basically, let me tell you the entire summary of this. So what happens is, you can see here that in order to install the Docker, we need the virtualization. This virtualization concept in the Windows environment uses kind of a Hyper-V. Now that is by default enabled if you are a Windows Pro user, but in case Windows Home user, you have to manually enable it. Now manually enabling requires you to go into the BIOS setting. Again, the BIOS setting is a little bit different for everybody. Some people needs to hit F3, some people needs to hit F9. So check out what is your vendor, and it will give you the information about the how to reach into the BIOS setting. Now here they give you amazing tools to check out whether this virtualization is enabled or not. So they give you this tool, SPECI, and you can find it out in the CPU Task Manager settings that whether this virtualization is enabled or not in your system. It should be enabled to run with the Docker. Now also, they also give you a Docker toolbox. Now, in the previous days, we used to work with by installing the virtual machines and then it installed the required softwares and stuff. But now they give you a toolbox and you can just click here and download this toolbox. Pretty simple. Next, yes, I okay, agree kind of a stuff. Once this is installed, then you can install the Docker in the regular way, which I have mentioned in the previous one. So again, looking into documentation is always a great idea. And again, there is no such like one rule to follow to how to go into the BIOS setting and enable virtualization. So it's different for Dell, it's different for HP, it's different for Asus. So make sure you find out your vendor and go into the BIOS setting and just turn that tab from virtualization enabled. Now that is out of the way. Now I would like to bring you back onto the topic, what is container? Now, in case you want to understand what is container, this diagram is ridiculously helpful. Otherwise, just imagining the thing, it's really difficult to understand the container. First, let me tell you how a regular application works in your computer. So here we can see that we have got a hardware level, kind of your hard disk, and in that you have installed the version of the Node. I don't really expect you to have thorough knowledge about Node. Consider this as any application, maybe PHP, maybe Python, whatever you like. It's pretty easier to understand with the help of Node because Node actually runs with a variety of versioning. So let's just say this is the hardware, your hard disk, and in that we are installing a Node version 7.4. Now, in the regular, when you are a new user of Node or any application, you just want to install everything to be latest. In the real world production, this doesn't happen. Even upgrading to a minor change, it's very difficult, and we do a thorough testing so that application doesn't break down. So every single version, what kind of support they are providing, it's very important for application. So consider this application as a production level. We are required to have a 7.4 version of this application that is running on the home page, let's just say. Now on top of this hardware level, we know that we have our operating system, we have our kernels and all these kinds of stuff, pretty basic one. And this is our application at the very top level. And in case you are wondering, what are these black guys with the dots coming from the top and the bottom? Now these are system calls. Your application makes some system calls to utilize the resources or through the kernel in your operating system, threads and all those kinds of stuff. So this is a classic application. That is how it's working on in your application. Now let's just say you want to test an application. At the top here, this guy is actually an application. So in this, we can see that this version, Node version 7.4, an entire application built in this, you want to run it. There will be absolutely no problem in that. You will be able to connect because in your hardware version 7.4 is installed, and voila, everything is all awesome. Now, what is going to happen when you want to test out an application which requires a version 7.6? And you might be saying, hey, no problem, we can upgrade to 7.6. You come up here and you just go ahead and upgrade 7.6. But the issue is now this application version 7.4 is not going to work because you have updated the application. And installing multiple copies of Node is really difficult. It's not really easy that you can install multiple instances of different versions of the node. So how we can reduce down this problem and how we can do this? Now in our hard disk, we have a concept of known as namespacing. In case you have worked a little on the C++, you might be able to connect with me. In case not, no problem at all. Let me help you to understand that. So let's go for the version 7.4 again. So what happens is in your hard disk, this grayish box that you can see, this is known as containerizing of your hard disk. There are some segments that you can make. And what I can do is I can just move it to as a copy of this one here, and I can upgrade or can install a fresh copy of whatever version is required. This is known as segmentation, or also known as namespacing in the concept of operating system world. So this is how it goes on. A separate dedicated disk space for installing this version of the software. So similarly, other version can be installed here. So this reduces down the problem. This segmentation, this namespacing reduces down this problem to have multiple copies of the same software. So this is great and this is nice. And now it brings down, okay, we got the concept, but what is container inside it? Now, what happens in the process of container, if I just go and get a border, I'll get a little bit of border. What happens, oops, didn't want to do that. Okay, not like that. So let me tell you what happens is that when you actually containerize this entire application in this manner, then this is known as a container. So let me just bump it up. So this box that you can see here is a container. And what does it contain? It contains your application in the exact state that you are trying to run. It includes some of the system calls, of course. It includes some part of the kernel. Remember, it doesn't contain the entire kernel. It doesn't need to. It contains some chunk of OS which are absolutely required to run your application. Maybe Ubuntu, maybe Windows, maybe whatever. And also it includes some part of the hardware specification so that wherever you can deploy this, it can consume exact same segmentation there. So this block here is actually your container. Pretty easy to understand. Some chunk from your application, some chunk from your kernel, and some chunk from everywhere. Exactly precised a containerization so that you can run your application wherever you like. Now, if you put this block on any machine, it's gonna just work. Regardless, you have a base of Windows, you have a base of Mac or Linux, because it is so well containerized. So there we go, a nice and easy way to understand what is container. But you might be getting confused here that it looks like almost virtual machines. What's going to be the difference between having a container and having a virtual machine? And that's what we are going to talk in the next video. So that's it for this video, and I hope you're enjoying the video. Please do share them as well so that other people can also take advantage of this series. Hit that subscribe, and I'm going to catch you up in the next video.